This video is being prepared for the Uniting Church Icon School class for September 2022, and in it I am revisiting sessions that I first did in 2014. It's about the properties of pigments, particularly the pigments that we use in our classes, in our school. It was a project, a document that was first compiled by one of our much loved members, Rita Magris. She compiled this back in 2007, and I added to it about 7 years later, and I've added a little bit to it this time as well. The document runs to about 32 pages, but I'm only going to focus on some of the pigments in our catalogue, in our shelves, because of time and also of interest. To start with, to say that the pigments are divided into a number of main topics, and I'll read these to you. Firstly, there are the ochres. Earth ochres, ground from sedimentary rocks and clays, ranging in colour from yellow through red and deep orange to brown. They contain hydrated iron oxide. Red ochres have a higher proportion of hematite. Sienna and umber belong to the ochre family but contain manganese oxide that gives the darker tones. For example, red ochre. The ochres are classified as being mineral rather than organic, and as being chemical rather than natural. And they're safe, they're not toxic. The next classification is oxides. They're also derived from rocks, clays and irons, but are manipulated, usually by heating, to change their properties. They are bright and opaque, and a good example of this is chromium oxide, so that's a green hue. And they are also safe, usually stronger, so that, for example, yellow oxide is the same hue, the same colour as yellow ochre, but is stronger. You don't need as many coats to make a good, strong outcome. The next category is cadmium. These pigments contain cadmium, and they're highly toxic and are banned in some countries. The element is present in the manufacture of some electric batteries. They are bright and opaque. Cadmium red is the best example of this. We also have cadmium orange. It's a very bright orange. There's a cad yellow as well. The next category is burnt. Usually ochres that have been treated with heat, as the name implies. The process also lends a red hue to the original. Now, it doesn't change all ochres, but it does for things like umber, so raw umber and burnt umber. Burnt umber is a redder version. Burnt sienna is another good example. One category that is not included in this document, but really should be, is titanium. Because since we wrote this document back in 2014, we've been discovering a few other titaniums apart from titanium white. And we now have unbleached titanium, which is a low chromium yellow, and also more recently the lovely titanium grey. So let's have a look at some of the main colours in this selection of pigments that we have on our shelves. Much of the information that comes into this document that Rita compiled, I suspect came from this book, The Painter's Handbook, which is by Mark David Gotzigan. And it has this large section in it on all the pigments, and it has a sort of a blow-by-blow description. And what I mean by that is that it not only tells us about its name and its classification, whether it's natural or chemical, organic or mineral, how it wets, what its characteristics of coverage are. It also has, and quite helpfully if you're wanting to find a particular colour in some other place, the colour index name. For example, ultramarine blue has an index number of PB29 in brackets 77007. Now, all fascinating stuff. More interesting is the provenance. So it will say when the colour or the pigment was found and where, and sometimes by whom. So ultramarine blue is a natural pigment found between 1200 and 1300, but there's the artificial pigment, which is what we have today, was discovered in 1828, accidentally. I don't know whose accident was it? A Frenchman by the name of Guimet. These bits of information for the purposes of painting might be interesting, but not as helpful as other bits of information. One of the things that this document does have in capitals is whether it is hazardous. So it will say whether it is toxic or not. Now, not many of our pigments are toxic. The main ones are the cadmiums. Cobalt blue is toxic, but on the bottle there is always a large warning. Some of them are hazardous in terms of inhaling. Avoid inhaling, particularly the very fine ones, because they're quite dusty and are more likely to get up your nose. What I thought I would do, rather than giving all this terribly interesting information in this video, is it's much handier to have that available for people to read, but to say a little about the more essential characteristics, so that the ones that are helpful to us as painters. So I've started with their classification and divided them into natural or chemical. Now, this isn't so essential. So you'll notice from this list that the vast majority of our pigments are natural. There are the chemical ones. The cadmiums are obviously chemical, as are the blues. Then there's the classification according to composition, whether they're organic or mineral, and again the vast majority of these are mineral. That is, the ochres or the ferric, the iron-based pigments. Another helpful, and probably it might even be the most helpful of the classifications, is the coverage. What kind of coverage does a pigment give? And this is helpful in terms of, well, how many coats will I have to put on in order to make this colour really show up? And there are some that are quite streaky. Helpful, nice, but streaky. So, for example, if you wanted to make an item of clothing terre verte, which looks nice in the bottle, but let me tell you, you'll need about 500, that's an exaggeration, you'll need a lot of coats in order to give a coverage. It's very streaky. Not only that, but when you have given it all that coverage, it doesn't come out as that nice pale, subtle green. It comes out really dark. What is typical of this colour is that it lends a tint to other other paints. It works really quite well with white, because then the white gives it good coverage, particularly titanium white gives it really good coverage, but is nicely tinted by this colour. So watch out for the streakies if you're wanting to use them on their own. The opaques will cut out all the white behind the nice gesso board. That will, your cadmiums and your titaniums are quite opaque, so they will be strong colours on their own, will not need a lot of coats. Some of your ochres also, particularly, for example, red ochre does not need a lot of coats. It is really strong. In the yellow range, if you're wanting a stronger coverage and not so many coats, then yellow oxide is going to be better than yellow ochre, even though the hue is much the same. Another, again, a minor consideration is how easily does the pigment mix? How much grinding do you need to do? And most of them, a little, a bit of a, you can almost do it with a coarse brush. But others that need moderate or even substantial grinding, particularly, say, burnt umber, it's quite a coarse pigment and really needs to be worked on to get it working in with the egg tempera. Now here's a trick I learned from Olga Shalomova. It is helpful for working out what your pigments will look like. And say for planning an icon and you want to use certain colours and want to see how they will behave, and particularly what will happen when you highlight them. So I've put raw, just straight egg tempera onto this piece of paper, and with a number 3 Kolinsky brush I have dipped it, it's damp, and I've dipped it into the raw dry yellow ochre and done a swatch onto the paper. Then I've put it into the titanium white to see what happens when you add white to it. Again here for the Ercolano red, let's see what happens when we add a highlight to that colour. So we can see straight away how it will behave. Clean off the brush, dip it into another piece of pigment, this time Mars orange, into the titanium white. What happens when you add white to that? And we can see straight away how it behaves and what it will look like. What about ultramarine blue, colour that I use a lot? How will that behave? can see straight away that it has some translucence to it. And what happens when you put white with it? What sort of blue will it make? And will I like it? Then that streaky terra vert, lovely colour, but on its own, what happens to it when we pop it on the page? Well, yes, like we said, it's streaky. What happens when we add white to it? Well, it's a really nice pale green, which spreads quite nicely. So we better just label these so that we know what we have painted for future reference. Job done. Now, before I go, let me just say one more thing about Rita's really interesting and helpful breakdown of the properties of the pigments that we use. At the bottom of each page, she has firstly a comment about mixing with other pigments. So, for example, for cerulean blue, she'll say, weak and strong tinting strength depends on amount used, need grinding into other pigments, needs a great deal of grinding agent, that is the tempera. So she'll also suggest that you mix this colour with that one, not that one with this one. She'll have a preference for with what you add to what, so that can be helpful. The other thing that she'll have at the bottom of the page is pigments usage. So she says of a cerulean blue, a good glazing hue can be replaced with a brilliant manganese blue, which is probably the same hue but transparent. And she'll say, for example, of yellow ochre that it's useful for flesh colours. She'll say of terra vert that it's useful also for the shading in face colours. So that's a helpful section of each page of Rita's description of the pigments that we use. So I hope this has been helpful. Look at Rita's document, the one called Pigment Properties, and also, as I've said, helpful reference is this handbook, which has all sorts of stuff about painting, art in all kinds of forms.